Well, amyloid scanning has been a very important advance, I think, in dementia. So we know that in Alzheimer's disease there are two proteins that are particularly laid down. These are amyloid protein, which form plaques, and tau protein that forms tangles. And until we had amyloid imaging, we could never visualize these directly. We'd always be looking at indirect measures of the protein breakdown, for example, shrinkage or atrophy on a brain scan. But certainly they offer us an opportunity to visualize amyloid in patients in the clinic when we couldn't otherwise. And this can be very useful in some situations when the diagnosis is very challenging after our current diagnostic workup. It'd be very useful to know if people have raised levels of amyloid in their brain, which would point us towards a diagnosis of Alzheimer's disease or another dementia that's associated with raised amyloid levels. And conversely, if they don't have evidence of raised amyloid, it will point us towards the fact they don't have Alzheimer's, which might mean they don't have any dementia, or it might mean they have a dementia not associated with amyloid, such as frontotemporal dementia. There's a challenge though as people get older, because normal people lay down amyloid at a certain rate. And so when we look at people in their 70s and 80s, quite a few healthy older people will have raised levels of amyloid. So it means that it's much more difficult for us to interpret the meaning of these scans as people get older. I don't think amyloid imaging is ever going to be used on its own to work out what people have. It's always going to be as part of a full clinical and diagnostic workup and assessment, where we put all the information together. We look at the onset of people's symptoms, what symptoms they have. We look at their brain scans, what changes there are on structure, and would you then, in some circumstances, use information from amyloid imaging to either help us support a particular diagnosis or point us away from that diagnosis.